Hello, so we have a question here where angle theta lies within the first quadrant and cosine theta equals 1 over 3. So first, this isn't an angle we're familiar with, and I'm looking at these questions and you can already see that we most likely do not have to solve for theta in these questions. So, so how do I solve this without solving theta? Well, we have to use the most basic element of right angle trigonometry. So we know that, let's just say this is theta. Well, opposite, or cosine theta, will be the adjacent over the hypotenuse. So this will be 3, this will be 1. If you want to know sine theta, well, that's going to be the opposite over the hypotenuse. So we have to first find this length, and we can use the Pythagorean theorem. So a squared plus b squared equals c squared. Well, let's rearrange it. So that means that b equals c squared minus a squared and the square root of that. So we know that b is equal to square root of 3 squared, which is 9, minus 1 squared, which is 1. So b equals root 8. So we'll just put root 8 right here. Okay, so opposite over hypotenuse. So opposite is root 8. The hypotenuse is 3. So sine theta is root 8 over 3. And then tan 2 theta. Okay, well first we have a double angle here, so we're going to have to use that data booklet reference. So let's plug in the values. Well, 2, 2, and then tan. Well, tan theta will be equal to the opposite over the adjacent. The opposite is root 8. So times root 8 over the adjacent. The adjacent is 1. So that's just root 8. So 2 root 8 over 1 minus tan squared theta. Well, 1 minus tan squared. Well, we know that tan is just root 8, so we can just do 8. Okay, and that turns into 2 root 8 over minus 7. So that's just, we can actually break down the square root. Let's do that. So 2 root 2 root 2 root 2 minus over 7. Sorry, that doesn't look nice. 7, the minus is over there. Then we can collect these, the root 2's, so it's minus 8 root 2 over 7. And that's what, oh, my bad. Sorry, my bad. That's a 4. 4. The root 2 and root 2 is 2 times 2. Okay, so this is what tan 2 theta equals. Minus 4 root 2 over 7. Okay, I'll just circle my answers. Okay, now the last question. Cosine theta over 2 expressed in the form of root a over b. Okay, well first we're going to have to use this data booklet reference. So let's manipulate that. So what we have here is, right now we're trying to, theta over 2, we're going to put that in the place of theta. Okay, so we have that formula, and what we can do is we can add 1 on both sides. So cosine 2 theta plus 1 equals 2 cosine squared theta, and we can just divide on 2 by both sides and the square root. So cosine 2 theta plus 1 over 2 square root equals cosine theta. Now keep in mind we're working with halves here, so actually the way this works is all of the thetas will be over 2. Okay, and so therefore that, I'll change it right now actually. So this will be theta, this will be theta over 2. And that's how we solve. Okay, so first cosine theta, well that's adjacent over hypotenuse. Adjacent over hypotenuse, that's 1/3. So 1/3 plus 1, I'll do it like this, over 2 square root. That's equal to 4 over 3 over 2 square root of that. So first I'm going to times 3 on both sides of the fraction. So we get, we're going to get from that, we're going to get root 4 over 6. Well, it says we have to express it in a term where only there's only a has the root. So what we're gonna have to do is we're gonna have to multiply this until it gets into a root, and I believe we can multiply by 1/2 or 1.5. Sorry, so that will equal root 9, and this is 6. Okay, so then we can take that. I just move it over here. Then that becomes root 6 over 3. So the answer of this is root 6 over 3. We just applied the square root to the 9 here. And that this won't be negative because it's in the first quadrant. So the answer for these questions are circled here.